Hi everyone, my name is Joyce. I'm a rising senior majoring in chemistry and minoring in communication arts, like Kawana said, at Washington and Jefferson College, just outside of Pittsburgh, Pennsylvania. So this summer, my research project focused on trying to synthesize the new solid form of the drug dapsone using a technique known as mechanochemistry. So this research could benefit the pharmaceutical realm as it could open up the door to other possible novel solid forms of drugs, helping to enhance or tune their physicochemical properties, which I'll get into on the next slide. So as you can see here, there are various types of solid forms, but it's important to note that each of these solid forms are meant to describe the same drug. These all have different physicochemical properties that are unique to them, things such as solubility, stability, bioavailability, etc. So we are going to focus on complex integrative forms of salts and solid solutions. These include polyheterosalts and ionic solid solutions, as the objective of my project was to synthesize an integrated form with characteristics of both a salt and solid solution. This is known as a polyhetero ionic solid solution. It's a novel solid form, and we specifically looked at the drug dapsone because there are many salts that already exist in the literature. However, these were all made using solution-based techniques, and we wanted to find a greener, more environmentally way to synthesize them. So we use mechanochemistry because it provides great alternatives to solution-based methods. So it has advantages in speed, environmental costs, and efficiency. Within it, we used a technique known as ball milling. Although this isn't the exact type we used, it still helps get the point across. So in ball milling, there are balls that grind the reactants in a jar, and they are grinded at really high speeds. This causes and generates energies on collisions, and that's what causes chemical or structural transformations. So afterwards, we have an unknown powder that we need to characterize, and then we use powder X-ray diffraction, PXRD, and solid-state NMR to help us determine what type of solid form we made. Moving on to results, we first compared the dapsone dichloride simulated version in the literature to the dapsone dichloride we mechanochemically made. So in this powder X-ray diffraction patterns, you can see that the peaks align based off of these green dashed lines. Based off of the peak matching, this tells us that we successfully used mechanochemistry to synthesize the dapsone dichloride salt. We did the same process for the dapsone dibromide salt. Again, with peak matching, you can see all of the peaks align, telling us we successfully made it again. Finally, we combined free-base dapsone, HBr, and HCl to try to create a new solid form. And this time, you can see that the peaks are similar yet distinct from those above. Because these peaks are not all the same, this tells us that we likely made a new solid form. But to confirm this, we have to turn to solid-state NMR. So in a crystalline salt, such as the dapsone dichloride, the chloride ions are all in the same local environment. So this is what yields these sharp defined peaks or horns, as you can see in the red spectrum. Whereas in a solid solution, bromide ions randomly substitute in the crystal lattice, causing volume displacement within the cell. Because bromine is larger in atomic size than chlorine, this is what causes the broadening of the blue spectrum or the roundness that you can see in comparison to the red one. Finally, we successfully synthesized the literature salts and a novel solid solution using mechanochemistry. Since then, we have tried to make a novel solid solution using nitrates, and as you can see here, they unexpectedly turned red. So we need to do further analysis to see why that is, but we suspect a chemical reaction is taking place. Other future work includes scaling up this process as it could benefit pharmaceutical companies and the end consumer. We also want to look at polyheteroionic solid solutions of other drugs and see if we can form those. Overall, you can see that mechanochemistry not only allows us to create molecular building blocks, but also to assemble them into new solid forms. Thank you.